Now, folks, let's take a look at this video 14 30. And we're dealing with individual branch circuits now. You remember we've reviewed the general purpose circuits, the small appliance circuits. Now we're going to review the individual branch circuits. Three groups now, remember, that we want to divide our loads into. Now this is the final group, individual loads. Now before we get into the video here, I would like for you to turn with me, if you would, to page 287 in your code book. And on the left-hand side of page 287 in your code book, you pick up 422-10A with the title head, Individual Branch Circuits. And that's what we're dealing with. Now, to save time, let's just drop down to the third paragraph, and it reads, the branch circuit rating for an appliance that is continuously loaded other than motor-operated appliances shall not be less than 125% of the marked rating or not less than 100% of the marked rating if the branch circuit device in the assembly are listed for continuous loading at 100% of its rating. And then the last paragraph there, just basically, we don't fall in our table 220.55. Heating loads are exempt from that. We just don't get into that. And then the overcurrent protection is 422-11, and let's just look at A. And it says your branch circuit rating has to comply with 240.4. So we're in 240.4. We either protect the circuit or we're going to figure that continuous duty, size the conductor, and move up to the next size overcurrent device. But there's something very important here, that we read. It does say here that the branch circuit shall not exceed the protected device rating on the appliance. If the appliance has a maximum circuit breaker rating or fuse rating, we can't exceed it. Now we can be lower, but not higher. But you always have to make sure that the overcurrent device is sized in such a manner you don't get a nuisance trip when all the heat is called for. Now you know that usually the heating elements is subdivided. They can be in 5 kVA, and you would have kVA ratings of 5 kVA added together till you got a certain rating. For example, you could have 5 kVA ratings, and 4 of them, that'd be 20 kVA, wouldn't it? So, or you might start at 10 kVA, and go up. It depends on how the manufacturer arranged the elements and how they would be subdivided and connected and so forth. But now, notice when we review this figure 14-30 from Stallcup's Electrical Design Book, Volume 2, then notice we have the overcurrent device, and we have to meet 424.3b, 240.4b, as well as selecting the overcurrent device from 240.6a and table 240.6a. Sizing the conductors, 424.3b. We're using THH in there, and we're pulling the conductors in a raceway here. And then notice you have a disconnecting means in accordance with 424.19. The heating element consists of elements of 125 kW, and the blower motor is 2 amps. Now, to do the calculation, we'll look at the quick calc. 424.3b, 125 amps plus 2.5 amps. I said 2 amps, it's 2.5, excuse me, times 125%. Now notice you're taking both here, and you come up with 159 amps. We reference our table 310.16 and our table 240.6a, referenced from section 240.6a, And 159 amps requires a 2-aught conductor. Good for 175 amp in the 75-degree column as required in 110.14 C1 little a in your code book. Now the 159 amps requires a 175 amp overcurrent device, because that's the next overcurrent device above 159, and the 175 amp overcurrent device also protects the number 2 wire and the heating elements, and the motor will naturally have a built-in thermal protector in most of those size motors. So the conductors are 2-aught, THHN or THWN, whichever, in the rating for in a dry location. And the size of the overcurrent protection device is 175 amp. So that's basically what we would do. In other words, we're going to have to connect it to the 75-degree column for your THWN copper conductors. And again, that's in accordance with 110.14 C1 little a for our terminations and a load of this capacity. And you say, well, now, isn't that 100 amps or less if I should use 110.14 C1 little a? That's correct. And so you would look at this overcurrent device at 175, and your load, connected load, is 175 and 2.5 for your blower motor. So you would look at 110.14 C1 little b, and you would be in the 75-degree column automatically. So this is individual branch circuits to individual pieces of equipment. That would be our third groups of load. Remember, our first group of load is the general lighting load, 3 VA per square foot. Then the small appliance circuit loads had to have 3. And now we're looking at the individual loads and seeing how they are determined. And that's basically what this figure 14-30 is illustrating: individual branch circuits and loads and equipment. Now let's take a look at this figure 19-1A. And it deals with an individual circuit to an air conditioner, an AC unit. Now notice in the figure loop for calculating values, see your figures 19-9 and 19-16. For the service conductors, 230.42A1, we'd calculated 125% of the continuous load plus the non-continuous load that operated less than 3 hours, and then loads with demand factors. But we'd apply 440.34 because we have combination loads here. It's receptacles, lights, appliances, and AC unit, and so forth. The overcurrent device is sized by 230.90A, or with one of the exceptions to 230.90A. 440.22B as in boy now deals with sizing the overcurrent protection device. And then the maximum circuit breaker here is 40 amps, maximum fuses 40 amps, and the branch circuit, THWN number 10 conductors, are all listed on the nameplate. Now, this nameplate ties directly with a branch circuit selection current. So I'm going to ask you to turn in your code book with me, if you will, over to page 336, I believe it is. Yes, page 336, and on the left-hand side of the page, if you will, let's review 440.3C. Left-hand side of the page is the first title head, Branch Circuit Selection Current. Now this is important, and I'm going to kind of look at the last sentence of that paragraph with you. And it reads, this marking in 440.4C, this marking shall be provided by the equipment manufacturer and should be on the nameplates where the rated load currents appear. And of course, that's what you have here. So you have 60 hertz, three-phase or single-phase, whatever it may be. And then notice it's 18.5 amps, full load amps. 3.3 FLA for a quarter horsepower motor. And then it tells you at the bottom that the maximum overcurrent device is 40 amps or fuses. And then 26 amps is the minimum ampacity of the circuit, which is going to require number 10, see? So we pretty well get the branch circuit THWN copper, number 10 AWG copper conductor, see, that we're looking at. Now, with this information, we're done. All we have to do is provide what the nameplate said, a number 10 conductor and a 40 amp maximum overcurrent device. It could be smaller, but you couldn't go greater than 40. So this is when you as an electrician say you're reviewing your nameplate to see what the individual circuit rating and overcurrent device would be for an individual circuit to AC unit, as you see in this illustration. Now, you say, well, we do not have a branch circuit selection current. What would we do? Well, this next video will review the calculation procedure that would take place, and if you didn't know how to perform it, then you would get with someone in your group that would, or talk to the contractor you're working for, whatever it may be. Of course, now designers, they're going to know what to do because they perform this type of installation in design many times. So that's mainly this figure 19-1A. That's what this figure is illustrating. Branch circuit selection current values from 440.4C on page 336 in your NEC. Now let's look at this figure 19-1B, and we want to look at the code first so that we get a good feel for this individual branch circuit where you have to perform the calculation, because the nameplate branch circuit selection current does not list it for you. So now, first of all, let's go over to page 338 in the NEC, and on the right-hand side of the page, we pick up part 4 there, branch circuit conductors, and that's our part. We just scroll down to 440.32, and it reads, branch circuit conductor supplying a single motor compressor shall have a ampacity not less than the greater of either 125% of the motor compressor's rated load current or 125% of the branch circuit selection current. Now, we just looked at the branch circuit selection current. Now we're looking at item 1. We're going to take 125% of that compressor. Then we're going to drop down to 440.33 there on page 338. And it basically says that we have a compressor or compressors with or without additional motor loads. But we do have a motor load here. We have a condenser motor. So it basically says then that it's item 1, the sum of the rated current or branch circuit selection current, whichever is greater, of all motor compressors or compressor. The sum of the full load current rating of all other motors, and 25% of the largest compressor or motor full load current in the group. But we don't have a group now. That's why you have the parentheses for the S there, because we only have one compressor and one condenser motor. So we're going to look at 440.22A and 440.33 that we just read and looked at. And we're going to look at 440.32 also. But now notice in step 1, it's table 220.3 that refers you over to this section to size the load for the conductors. So the table here that you see in the illustration shouldn't be there. It's just 440.33. And 18.5 amps times 125%, because compressors are largest, plus a condenser motor at 3.2 comes up with 26 amps. Just what you saw on that nameplate, really, wasn't it? And then table 310.16 in step 2 would be 26 amps, and that would require a number 10 conductor that we would need either in the 60 or the 75 degree column, because we're limited by 240.4D there, but the overcurrent device can be sized larger to allow the air conditioner to operate under high head pressures and so forth, and table 240.4G is in gray. Now, step 3, we're going to size that overcurrent device, so we're going to reference table 240.4G, and it says, oh yeah, you can size up greater than the 125% in step 1. We're going up to maximum size, 225%. Now, when I say maximum size, that's in the section 440.22B1 and A there that we would look at. Now, 440.22B1, along with table 240.6A to select the overcurrent device. After we've done the math in step 3 now, 225% of 18.5, the compressor current, add the 3.2 condenser motor, 44.8, and we cannot move up. There's no exception in 440.22B1 or A that would let you move up. So we have to round down to 40 amps, just exactly what the nameplate called for, really. So we know we're using the maximum. Just a tip to you. If your air conditioner's on the roof, or usually on the side of the house where the sun shines from morning to solar noon to evening, usually you're going to use the maximum. But you don't have to. You can round that thing down here, see, to any size that would operate your unit and not have nuisance tripping. Now the solution then would be a number 10 AWG conductor, and it would be 40 amps is the overcurrent device rating. And really all of this is the same in the solution as the nameplate. Won't always be that way. See, they may use 175% in 440.22A. And you know, if you look at that on page 338, for example, and if you count down for this individual motor compressor, if you count down starting with the title head, 1, 2, 3, 4, 5 lines right there in the center is the minimum 175%. Meaning you can go below it. That's just a percentage you started with. And then start at the very bottom of the paragraph, which ends in greater, and count up 3 lines, and then you see the 225% rule, which again, you can always come down and round down, but you can't go above the 225%, just like you couldn't go above the 175% if you was using that. But this is just a good illustration here in 19-1B, showing when you do not have a branch circuit selection current on your nameplate, and you only have the values like 18.5 compressor, 3.2 condenser motor, then this is the calculation you would run. Most of the time now, you're going to have the branch circuit selection current, and as an electrician, that's all I have to go by, because all the math is already done for me, see. So just remember that 240.4D as in dog does not apply here, because you have to size the overcurrent device larger than the 125% rule in step 1 to allow that AC unit to operate under high head pressures and other operational conditions during the summer. So that's what this figure is illustrating to the user of the NEC.